All right, so we are starting chapter 13. So we're actually kind of going back to some stuff that we learned back in first semester. And so we are looking at equations again. Today we're going to be graphing linear equations. So that means we're going to graph straight lines. And we have already gone over the warm-up in class. So let's move on to our notes. So a linear equation is an equation whose graph is a line. And the points on the line are the solutions of an equation. So all the equations that we've been solving actually make a line, and those solutions are all points that are on the line. So anytime we found something that made the equation true, that's actually a point that's been on a straight line. So for example, we have the graph that says y equals 2x plus 1. So what we're going to do is make a table, and we're going to plug in some points. Typically, you use -1, 0, and 1. That way you get across the axis and you can see what the line will do in both directions. So first we're going to take our equation and we're going to plug in this x in the equation. So all of these x's are going to be plugged in one at a time, and we're going to see what the solutions would be. So we have y equals 2 times -1 in this case, plus 1. We have to use PEMDAS, and so we know that we have to multiply first. So we're going to multiply 2 times -1, and we get -2. And then we're going to add 1. So -2 plus 1 gives us -1. And so we have -1 here. So let's do that for all of them. So y equals 2 times 0 plus 1. And so 0 times 2 is 0. And then plus 1 gives us 1. So we have positive 1 here. And then y equals 2 times 1 plus 1. So we have 2, because 2 times 1 is 2. And then plus 1, which gives us 3. And so now we have to write these as points, as if it's on a graph. So we are going to just take our x's and their new y's, and we're going to write them as a point. So -1, comma, -1, 1, or sorry, 0. So when we plugged in 0, we got 1. And when we plug in 1 for our x, we got 3 for our y. So now we plot those on the graph. So remember, our center is always the middle of our axis. That's 0, 0. And our first point was -1, -1. So we're going to go to the left 1, down 1. That's our first point. And then we have 0, 1. So we don't move left or right, but we go up 1. And then our next point is 1. So we're going to go the right 1, up 3. 1, 2, 3. And so we get 3 dots. Don't just don't just put the dots on the graph. We have to turn it into a line. We know that we are making linear, or we are solving linear equations and graphing linear equations. So that means that we are going to turn this into a line by connecting all 3. And when we do this, we always need 3 points on our graph, and we always need our lines to have arrows. And our graph, our lines, always need to go all the way off the graph. So there's always 3 things that you need to do. So we did 3 points, our lines have arrows, and we took those lines all the way off the graph. That shows that our line goes on forever. All right, so I want you to do the next one, and then you're going to check your work with mine. All right, so when you plug in -1, -1 times 3 is +3, plus 2 is 5. When you plug in 0, -3 times 0 is 0, plus 2 is 2. And when you plug in 1, -3 times 1 is -3, plus 2 is -1. So I rewrote my points, and then I graphed them over here. And so you'll notice I have my 3 points, and I have arrows, and my line goes all the way to the end of my graph. You'll notice that this graph up here is going upwards, while this, so when you read it from left to right, it looks like it's going up. And when you read from left to right, this one looks like it's going downwards. The reason this one's going downwards is because of this negative here in the front, while the other graph was positive. So all positive graphs go upwards like this, and all negative graphs go downwards like this. All right, so now let's look at graphing in horizontal and vertical. So horizontal and vertical is a little bit different. And so when we graph these, it already tells us what our y equals. So no matter what, whenever I plug in an x, which there's not an x, I always will get a -3. So you always will plug in, your first point is always going to be 0, comma, whatever that number is. So -3. So 0 go up 3, or sorry, go down 3. And then no matter what, it's always going to be -3. So it's going to be a horizontal line. So no matter what point you're at on the line, it'll always be -3. When you are graphing something that looks like x equals, no matter what, your x is, your first point is always going to be this, whatever x equals, so in this case 2, and then a 0. And so no matter what, or no matter where I am on the line, I'm always going to be at +2 for my x. So this is going to be a vertical line that goes up and down. All right, so now I thought that I had an extra practice for you guys, but I don't. So now what you're going to do is the real world situation. So the wind speed, y, in miles per hour of a tropical storm is y equals 2x plus 66, where x is the number of hours after the storm enters the Gulf of Mexico. When does the storm become a hurricane? So it says a tropical storm becomes a hurricane when the wind speeds are at least 74 miles per hour. So if we didn't have a graph, what we're going to do is plug in some points. And so we're going to plug in for our x. We're going to plug in 0 because we can't have negative hours, but we can't have a starting point. So right as the storm hits, it could be a hurricane. 1 hour, so 1 hour after the storm hits. 2, so 2 hours. 3, and I should have added one more for you. So let's add an extra box. And let's do 4 hours. So at 0, you will see that we get 0 times 2 is 0, so plus 66 is just 66. So we haven't hit that 74 yet, so we're going to do this until we hit 74. So I want you to pause the video and continue the next 4 on your own, and then check yours with mine. So you'll see that after, it wasn't until we hit 4 hours that we got a y that equaled our 74 miles per hour. So this means that after 4 hours, our wind speed finally hit the speed that's considered a hurricane, which is 74 miles per hour. You can see over on the graph that they plotted the same points that we got, and then if you look at our very last one at 4, it gave us 74. And so we know that our table matches our equation or our graph. And so you could have used the graph. However, you will most likely be asked to graph on your homework. So I wanted to make sure that you knew how to get your points first before just jumping right in to look at the graph to see what it would be equal to. All right, so the rest of your time is used to work on the homework.